Hello everyone, my name is Venkatamani. Today I'm here to present about our project proposal, which we are doing as a part of our course curriculum course, Deep Learning Neural Networks. The title of our project is Tomato Leaf Infection Detection System. So basically in this project, we are going to use convolution neural network models to detect the infections that are present in tomato leaves. So me along with Sivarahul Gupta and Amay Salve are going to work on this project. Coming to the problem statement of our project. So if you observe, tomato farmers everywhere face economic loss and crop waste due to various infections in tomato plants. Yes. And if you try to go in depth in this research, so you'll get to know that, and most of these infections are through leaves. So if you are able to identify these leaf infections in tomato crops, we can improve the yield and as well as reduce the loss for tomato farmer. But how we are going to do it? One thing we can do is manually identifying each and every infection that is present in the leaves, but it will be very time consuming and it will also have multiple errors while detecting because humans are not always right. They might have some errors while trying to identify the correct infection. So in order to improve the efficiency and accurately detect the infection, we can deploy some deep learning techniques here, and one of which is convolutional neural network and its variations, which we are going to use to solve this problem. And there are like 10 classes of instructions in our data set, which we are trying to detect using the CNN and its variation model to our project. Um, from here, my teammate Rahul will continue. He'll discuss about the data set and what are the terms we done so far.
Yeah, hello everyone. So coming to data overview, so for solving a problem, we took a data set which has a various tomato leaf infection images in all are in JPG format with a resolution of 256 by 256 pixels with RGB color. So this data set is balanced in terms of class distribution, which has 10 classes of tomato leaf diseases, and we you can see all the classes which have been listed here. This dataset has around 10,000 images for training, which has 1,000 images for each class, and also uh, 1,000 images for validation and for 100 images from each class. Overall, this tomato. So here you can see the sample images from our dataset. These are the images which represents each class name and the image for the the tomato disease. And coming to the what I've done so far, so we for the project we took the data set. We took from the many research papers, and after doing the research on this, we got one from the Kaggle, and we also try to use some different methodologies, which includes the data. We also for data exploration and data pre-processing, and after pre-processing, we have researched different CNN models and architectures for such as LeNet, ResNet, and VGNet. So this is what we did for far. So now Ame will continue the rest.
All right. Hello, everyone. So based on what Rahul mentioned, what we have done so far, so the next steps that we are planning to do is first sort of understand what the data set is about and explore it a little bit further to understand like the actual nature of the data set, such as the size. As mentioned before, like we have 10 classes, but look at the distribution a little bit more and understand like what the quality of the images are, if they are suitable to be used or not, all of them. And that'll take us to the next process, which is the pre-processing. So in this, what we are going to do is take a look at the images and make sure that they are suitable for our model. That will include like resizing of them, normalizing the pixel values, and convert them to grayscale. Once we're done that and our data set is prepared and ready for use, we are going to experiment with various CNN architecture models, such as mentioned by Rahul, Linnet, ResNet, Inception, etc. And we'll be using various optimization techniques as well, like ADAM, RMS prop, gradient descent. And we'll be testing with like different hyperparameter values, etc., just to make sure to try out different models and see which works the best. So eventually, of course, we'll look at each model's performance on the test data set and try to identify which model performs the best, and that will be chosen. So what we are expecting based on the results is that we would want to aim for a CNN-based model that will have a minimum accuracy of 80%. Of course, we would prefer to have an accuracy model which is much more higher than that, but the least accurate model that we'd be aiming for is around 80 to 85%. That is what our minimum expectation is. So yeah, those are like the initial plans that we have. These may change and we might modify the steps a little bit to make sure like once we understand more about the data set, etc., and more about the process, we might change it around a little bit, but this is the initial plan. And these are some of the references that we used while going through like most of the process. And yeah, that's it. Thank you very much.